distribute each one of these separately. So we're taking this 4x, and we're only distributing it to the parentheses that it's next to. So 4x times x is going to give us 4x squared. And then we have to do 4x times 6, and that is going to give us 24x. Now here's the thing, most students are going to mess up on the second part because there's not an x with the 6. There's only just one single x right there, so you'll just leave it alone. So here we got the square because we had one x here and we had the other x here, so that gave us a square. But for this, you just got the x on that one side. Okay. The next thing that students usually mess up here is when you distribute this next part, you're distributing the negative 8, not just the 8. So it's going to be negative 8 times 2x squared. And negative 8 times 2x squared gives us negative 16x squared. And then we've got to do negative 8 times negative x right here, and that is going to give us positive 8x. Now, for this one, are we finished? We are not, because we have like terms that we can combine, which you guys were doing pretty well with on the Delta Math. We've got a 4x squared and a negative 16x squared. So if I put those together, I'm going to get a negative 12x squared. And then also we've got a positive 24x and a positive 8x. And if I put those together, I'm going to get a positive 32x. Notice there, I did not change my exponents. When you combine like terms, you're not changing your exponents at all. Okay, questions? Okay, so now things are going to get a little bit more complicated. Not really. It's the same thing. The problems just look a little bit different for these. So, for example 4, we're going to have 2x plus 3 times x minus 5. Alright, so this one is not the same as the last problem because I don't have a number out front that I'm distributing to the parentheses here. Okay? So, I'm going to have to distribute one set of parentheses to the other set of parentheses. Okay? So, Dakota, you remember what it's going to look like? Alright, so we're going to take this 2x right here, and we're going to distribute it to the x. What does that give us when we do that, Dakota? Yep, 2x squared, very good. And then we got to distribute that 2x to the negative 5. And what do we get whenever we do that? We get negative 10x. Okay, and see the problem is here, I've taken care of like everything except for I haven't used this 3 right here at all. Right? So it also has to be distributed. So I've got to distribute the 3 to the x. What does that give me, Dakota? A 3x. So we got plus 3x. And then 3 times that negative 5. What's that going to give me, Dakota? Negative 15. So you're still distributing here, but you've got to distribute twice. Now, Gabe, are we done? Is this the answer? We're not. What can we do? Very good. And what will we get for our answer whenever we do that? Good. So we get negative 7x whenever we put these two right here in the middle. Now, the 2x squared, we cannot combine that with anything, so we've got 2x squared, and the 15, we've got the 15 over here. That does make sense or no sense? Okay. Okay. Any questions on that? Okay, let's do another example. Okay, so, okay, good. We got to do x times x. We get x squared. Very good, Julie. What next? Very good. Is it plus 4x or minus 4x? Plus 4x. Because we are doing this positive x times that positive 4 right there. So when we distribute that x, we get x squared plus 4x. All right, what will we do next, Julie? Negative 8 times x. What's that give us? Okay. Do you have an x with your 8? You do not. You only have one x right here, so it's just going to be 1x. I mean, 8x, but there's only one of the x's. X to the first power. Very good. Negative 32, and there are no x's at all with that last one, because negative 8 times positive 4 is just going to give you negative 32. Okay? We're not done, though, Julie. What are we going to get for the final answer? Good. And what are my like terms? 4 and what? Good. And when we put those together, what are we going to get, Julie? Very good. We'll have a negative 4x. All right. And none of the other stuff can be combined, so you just got x squared and 32. All right, questions so far? I got us a couple special ones to show you. Let's do example 6. Okay. Example 6. Let's do 3x plus 2 times 3x minus 2. All right, Ian, this one's yours. What would we do here? Very good. What's that going to give us? Squared. Good. All right, then what would we do? Good. Very good. 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 And you'll get 0 whenever you combine those, right? So they cancel each other out. So you're only left with the 9x squared and the negative 4. So when this happens, when you have those middle terms cancel out, this has a special name. So over here to the side, I'm going to put this here. This is called a difference of squares. Okay. And a difference of squares, I knew immediately as I made this problem it was a difference of squares because I had 3x plus 2 and 3x minus 2. Everything about those two binomials, each little thing in parentheses, was exactly the same except for the sign in the middle. So, like, just to give you another quick example, that is also difference of squares. Example 7, let's say 4x plus 1 and 4x minus 1. So whenever I see that, I, as a math teacher who has been doing this for a really long time and done this a whole lot, I know the answer immediately. I don't have to distribute, right? You guys have just learned this just now. I don't believe you've ever done this before, right? This is new. So I want you guys thinking through it a little bit. If you can do it in your head, that's fine. You're doing 4x times 4x gives you 16x squared. And you're doing 4x times negative 1, which gives you negative 4x. And then you're distributing the 1. So 1 times 4x is positive 4x. And 1 times negative 1 is negative 1. But if you have a difference of squares, those middle terms cancel out every time. So I knew as soon as I saw that right there that the answer was 16x squared minus 1. Because if you have a difference of squares, the middle terms will cancel out every time. So if you notice those, you can do them a little bit quicker because you don't have to distribute everything. It's just the first two terms, middle cancels out the last two terms. And you'll be able to do that a little bit quicker. So that's one special type. The other special type is going to look like this. And these, everybody always gets wrong. Not because they're that hard, just because they forget what to do with them. Alright, x plus 5 squared. Okay? Everybody always misses these. Okay? Not because they're hard, just because people forget what to do. Okay? Evan? It is not, but that is the wrong answer everybody always gives. Okay? Because when he said is it x squared plus 25, which seems logical, right? You square the x, you get x squared. You square the 5, you get 25. That seems like it should be the answer. But when we have x plus 5 squared, this is what it means. X plus 5 times x plus 5. So it means that you're multiplying x plus 5 twice. And so to do that, you've got to distribute, correct? So you would have to do x times x. That would give you x squared. That's what we had with Evan's answer. But then we'd have to do x times 5. And that would give you positive 5x. And then you would have to distribute this 5. So 5 times x would be positive 5x. And then we'd have to do 5 times 5, which will be 25. Now this almost looks like the last problem, except do my 5x's cancel this time? They're both positive this time, so they don't cancel. So your answer for this is x squared plus 10x plus 25. There is a shortcut for this one too, but I'm not going to teach it to you yet. If I teach it to you right now, you might get it mixed up with a lot of other stuff. So I'll teach it to you in a few days. These are called, if you write this down, these are called perfect square trinomials. So if you do it Evan's way, you miss the middle term, right? And guaranteed, if I put this on a quiz or a test, there's going to be several of you that do x squared plus 25 and forget that middle term. So whenever you see this, be aware you got to write it twice and distribute. Okay? Questions? Now, I usually don't teach this way, but there are a lot of teachers who do, so I'm going to teach it to you just in case you hear it from another teacher one time. So let's do another example. Example 9. Now, this is really not anything different than I've just already taught you. I just want to give you this word in case you hear other teachers talk about it. So, a lot of times to teach students how to multiply two binomials together, a lot of teachers will use the word FOIL, F-O-I-L, like aluminum foil. Okay? And this is just to help you remember what to multiply together. F stands for first. O stands for outers. I stands for inners. And L stands for last. I'm going to show you this is exactly what we've been doing anyway. I don't usually teach it this way. I just don't want you to get to another class and a teacher tell you that you need to FOIL this out and you have no idea what they're talking about. When they say FOIL this out, they just mean distribute. This just helps you make sure you've done everything correctly. So what we would do is we would take 2x and we would multiply it by 5x, which is what we've been doing, right? Those are both the first term in each parenthesis. So those are our firsts. So we've got 2x times 5x, which is 10x squared. So we're taking care of our firsts. Then we would multiply our outers. Does outers have two t's? That doesn't quite look right. I don't think so either. I think it's one t. That don't really look right. That doesn't really look like it's right either. I don't know if outers is really even a word anyway. This is a math. This is just to help us remember. Yeah. So, anyway, good enough. One or the other. All right. So outers. If we take the outside terms are 2x and 8. That's what we were going to do anyway, just distributed, right? So 2x and negative 8, and that's going to give us negative 16x. So we've taken care of the outers. I think it's better with only one. Then we would multiply the inner terms. So the two inside terms would be the 3 and the 5x. And that would give us 15x. That would be our inner terms. And then we would do our last. So 3 is the last term in this parentheses. 8 is the last term in this parentheses. And so that would be negative 24. It's exactly what we were doing already, right? It's nothing different. I don't usually teach it this way because it doesn't work if you've got more terms, which we're going to see in a minute. So I don't usually teach it this way, but you might get a teacher that tells you to FOIL that out. They're just meaning to distribute whenever they say that. So then we would just combine our like terms. So Bailey, if we combine our like terms, what will we get for our answer here? We'll get, good, we'll get a negative 1x right there in the middle. So we've got 10x squared minus x minus 24. Okay. Now the reason I do not teach the FOIL method anymore, I used to, because that's the way that I was taught how to multiply these. The reason why I don't teach this as the FOIL method anymore is because the FOIL method only works if you're doing a binomial times a binomial. 2 terms times 2 terms. But sometimes we get problems that are going to look like this one. Example 10 here. X plus 4. A few, what do you mean? So, kind of, we're going to have x plus 4 times x squared minus 4x plus 6. Now, first outers, inners, last will not work for this because you've got 3 terms in that second parenthesis. But distributing, like I have already showed you how to do, will work on this. So if we take our x and multiply it by our x squared, Aiden, what are we going to get when we do that? X times x squared. Yep, very good. X to the third. Then we have to distribute that x to the 4x. What do we get when we do x times negative 4x, Aiden? Perfect. Negative 4x to the second. And the last, we got to do x times positive 6. What do we get there? Good? Good. It'll be 6x just to the first power there, so we don't have to write an exponent. So this time I distributed, but I had to distribute to all 3 terms, right? And then I would still have to take this 4 and distribute it as well. So Connor, when I multiply that 4 by the x squared, what am I going to get? Very good. So I get a positive 4x squared. Then I've got to do 4 times negative 4x. What's that going to give me? Not quite. We're multiplying here. So we're not going to add the 4's together. We got to multiply those 4's together. So 4 times negative 4. Very good. Negative 16. And we just have x to the first power. And then we're going to have 4 times positive 6. What do we get there? Good. So positive 24. All right, Adam. Pretty sure you don't need that right now. Thank you. All right. So, questions so far? All right, Jesus, we got to combine some like terms. Help me out here. Okay. Right. We got a positive and a negative of the x squares. What happens with those? They cancel right here. Okay. So those don't really do anything. Then what else could I put together? Okay, good. Not to worry about the there for a minute. So that x to the third, we can't put it with anything. I'm just going to write it up front, right? The 6x and the negative 16x, that's going to give me negative 10x. And then just put the 24. So those problems are a little bit longer, but it's the same idea. Okay, we just got a couple more examples. Just two. Couple is 2. All right. Oh. FOIL definitely is not going to work on this because we got a 3 by 3 here. A trinomial times a trinomial. So these problems are no more difficult than the more simple ones in what you're doing, but they are really difficult to keep everything straight and not get it all mixed up. I'm going to show you, we're going to do 2 of these. We're going to do this one and one more example. And I'm going to show you a couple strategies that can help you keep it straight. Okay? So the first thing I'm going to do is we're just distributing just like we've done with the other problems. So x squared times 2x squared is going to give me 2x to the 4th power. And I'm going to do x squared times negative 4x. And that's going to be negative 4x to the 3rd power. And then x squared times positive 6 is going to give me plus 6x squared. All right, everybody with me there? Okay. All right, now we've got to distribute this positive 2x. So I'm going to do positive 2x times 2x squared. Now watch what I'm going to do with this. That's going to give me 4x to the 3rd power. I'm going to write that right here. 4x to the 3rd power. Why would I want to put it there? Because those two are like terms, right? So if I kind of line these up, sort of like whenever you're doing addition and you line up your decimal places, that's going to just make it a little easier to combine because otherwise you got a string of 9 numbers and getting everything put together is sometimes a little bit difficult. So I'm going to do this. And then so I've got 2x squared times negative 4x. That's going to give me negative 8x squared. Look, that lines up nicely right below the other x squared, which is going to help me when I'm combining my like terms. And then I've got 2x plus 6, so I get plus 12x there. But we're not done because we still got this 1 right here that has to be distributed. So I've got to distribute the 1 to everything in the 3rd parenthesis. So 1 times 2x squared is 2x squared. And notice right there, I lined it up with the x squareds. And then 1 times negative 4x is negative 4x. Look, it lines up with the other x's. And then my last term right there is the positive 6. Yes. Okay. All right. So, Evan, what are we going to get for our answer here? Good. Crazy stuff's happening, isn't it? Yeah, because 6 and 2 is going to give you positive 8, and then you got a negative 8 right here. So those actually cancel out also. That doesn't normally happen. It doesn't always happen. This happens in here. All right, then I'm going to put, good, we got 8x, because 12 minus 4 is going to give us 8, and we just put our plus 6 right here on the end. Okay, if I'm multiplying a trinomial times a trinomial, I either do this, or I'm going to do the box method that I'm getting ready to show you on the next problem. Because it is a little bit difficult to keep all the terms separate. Okay, questions? And this box method I'm getting ready to show you, you can do on even the easier problems if you really like it. Although, I will tell you, it takes a little bit longer to do the box method, so I usually only use it for the longer problems. So, let's say we've got 2x squared minus x plus 7 times x squared plus 4x minus 3. Okay, so if I'm multiplying 3 terms by 3 terms, I'm going to make myself a box. I'm using the box method that has 3 rows and 3 columns, so a 3 by 3 box here. Okay, and I'm going to take one of the polynomials and I'm going to put it across the top, and one of them goes across the side. It does not matter which one goes where. So 2x squared I'm going to put here. Then I've got a negative x over this one and a positive 7. And then this trinomial I'm going to put on the left side, so I'll have an x squared here, a 4x here, and a negative 3 here. And this is going to work like a multiplication chart. So if you remember back in the 3rd grade, your teacher might have given you like a paper, and it had 1 through 12 on this side and 1 through 12 on the top, and if you needed to know 4 times 7, you followed those boxes till you got to the right answer. So this works like that. So the answer that goes here is going to be 2x squared times x squared, which is 2x to the 4th power. Now essentially what you're doing is you're just distributing whenever you do this. Then you would do x squared times negative x, which would give you negative x to the 3rd. That would go in this box right here. And then x squared times 7, which is 7x squared. Okay, so what we just did there, I guess we took that x squared and we distributed it to all 3 of those. So the box just distributes for you. Then we would have to do 4x times 2x squared. That would be 8x to the 3rd. We'll do 4x times negative x, which would give us negative 4x squared. And 4x times 7, which would give us 28x. And so essentially what we just did there is we took this 4x right here and we distributed it to all of these. All right. I realize I'm distributing from like the back polynomial. You could do that if you wanted. We don't typically do that. And then negative 3 times 2x squared gives you negative 6x squared. Negative 3 times negative x gives you positive 3x. And negative 3 times 7 gives you negative 21. And so what you're doing there is just taking your negative 3 and distributing it to those 3. All right. The good thing about the box is this. Is typically, as long as the polynomials are of the same degree, if you look at your diagonals of your box, all of your x to the 3rds are in that diagonal, all of your x squareds are in this diagonal, and all of your x's are in this diagonal. Up here you've got the terms that you can't put together. So you would have 2x to the fourth here. Then you would combine 8x to the third and negative x to the third, which would give you positive 7x to the third. Okay. Then you would have negative x squared, negative 4x squared, and 7x squared. So this will give you negative 10 plus 7, so you get negative 3x squared when you put those together. 3x and 28x is going to give you positive 31x, and then you get a minus 21 on the end. You don't have to use the box at all if you don't like it. I just wanted to show it to you because some students, it helps them keep organized whenever they do it. But if you don't like it, you can do what we did on the last problem. You don't have to be able to do it. It does take longer, so I some students still, like if I had x plus 2 times x minus 4, I could make a box like this, x, 2, x, negative 4, and I could do that. I really don't want you to use the box on that unless you absolutely have to, because it definitely takes longer. But I do want you to get them right, so if the box helps you, then that's okay. All right. So, this is going to be your homework. I want you guys to do the odd problems tonight. Go ahead and get started. I think it's 24, so it's 12 problems. Okay, so only the odd problems on this worksheet tonight. Only the odd problems on this worksheet. Okay. I'll actually probably make Delta Math do Thursday because you're welcome. I will be glad to get you a computer, or you can go to the library and use a computer in the morning if you need a computer for Delta Math. You can also do it from home. I've got a faculty meeting Wednesday, so it'll be Thursday before I have tutoring. So by Thursday, Delta Math needs to be done. This is your homework tonight, though it's due tomorrow. Then when I call it answers, you won't have to have them. I'd probably still give you credit.